Now we're going to take a look at the inventory class, which makes it possible for collected objects in the scene to appear inside the inventory panel at the bottom here. So I'm going to bring into MonoDevelop the inventory class, although just before doing that, I'm going to select the inventory object here inside the hierarchy panel. When I select the inventory object, you can see that this is the object to which I have attached the script inventory. So I'm going to bring inside MonoDevelop here to have a look at inventory.c# and just resize MonoDevelop to the recording window. Now the inventory class has, in short, been coded as a singleton object. That simply means that there cannot be more than one instance of this class in the scene at any one time. That makes sense, technically speaking, because it's not possible for the player to have more than one inventory. The player has one inventory and can collect multiple items to that. So we have the public static property inventory instance, and this property always returns the one and only instance of this class. You will see that we are maintaining the reference to that instance inside the private static inventory instance object. So this is linking to the awake function, and let's take a look at how that works. When the object is first created, I'm checking to see whether the property, this instance, is assigned to any kind of reference to an object that is an inventory object. If there is an existing inventory object in the scene, because this instance has been assigned, then I just need to destroy the current object, because we don't want to duplicate the inventory. We only want one instance, and this one would be a duplicate. So I want to destroy it and exit the function. However, if this instance is equal to null, it means that on no previous occasion was an instance of this class made. And so therefore I'm assigning this instance to this particular instance. Notice that both the private static property here, this instance, and this C# property here, both of them are declared as static. That means that the variable itself is not specific to an instance. It is specific to the class overall, meaning that all instances effectively share this property. That is how the singleton pattern can work with static objects. So I'm going to scroll down just a little bit more, and we come across the function that really is the nuts and bolts of the inventory here, which is the add item function. We can see that this function is called from the inventory item.c# file. If I select that file, you will see that on the onTriggerEnter function, we call inventory.addItem. Notice that addItem is a static function as well, which is why we are able to say inventory.addItem. We don't need to access a specific instance of the inventory in the scene, because there is only one instance anyway. So I'm going to go back to the inventory.c# file, and for addItem it takes the argument of GameObjectGo, which is the object that the player collides with, and that's the thing that we want to collect. Now when we collect an object, I want to disable all the colliders on that object, because I don't want to be able to collect the same item twice. And I'm also going to disable the renderers on that object, because once collected, it should no longer be visible in the scene. Then once I have deactivated all the colliders and all the inventories, or rather all the renderers, then what I'm going to do is I'm going to find the first available slot inside the inventory that hasn't been assigned yet. That is simply this. If I go back to Unity here and have a look at the inventory object, if I expand that and take a look at the items list, you can see that we have many different slots. Now, I don't know which slot the object should be assigned to yet. Effectively, they should be collected in order and appear from left to right. So effectively, I want to find the leftmost slot that has not yet been assigned. And that is what this code here inside MonoDevelop is doing. I'm getting a list of all the child objects that are attached to the item list. So the item list is over here inside the hierarchy panel, and this has many different child objects. Each one is an item slot. I'm simply using the for loop to get the number of these item slots, and then I'm using the getChild function of the transform component, specifying the iterator here to get the first child, then the second child, then the third child, and so on. And for each of the children, I'm checking to see if the object has been activated. Now, if the object is activated, that means that it has been assigned. That is, we have collected an object and it appears in that slot. But if the item slot is not yet activated, it means an item has not been collected there yet. And so what I want to do is to grab the image component on that object, and then for the sprite field, I want to assign it the sprite that is part of the inventory item. Remember that the inventory item class, which is coded over here, contains a sprite field GUI icon, which represents the icon that should show inside the inventory when it is collected. So I'm going to go back to inventory.c#. That object, the inventory icon, is what is assigned to the sprite field of the image component. And then finally, the item slot is activated using the setActive function, and we are setting that to true. So if I go back inside Unity here and press play, and I move the character around, we can see that as before, when we looked at the project ahead of time, that I can move over objects, for example, the cube object here, and collect the cube, and it is added to the inventory alongside with anything else that we might collect. So I could collect the sphere and so on, and the cylinder there. So we have the cube, sphere, and cylinder all added to the inventory. And that is how we can go ahead and create an inventory system. So this completes this part of this course, and this has been 3dmotive.com. I've been Alan Thorne. I hope you found this part helpful. I can't wait to get stuck into the next part.